Alright, welcome you guys. This is going to be the start of a new series that we're going to be doing in which we are going to be talking about the endocrine system. In this first lesson, we're going to give a good overview of what the endocrine system is and what it's composed of. The goal of this first lesson is to give you a good solid foundation when we start to carry this conversation further about different disorders that you're going to encounter in relation to the endocrine system. Because in future lessons, we're going to talk about things like the difference between Addison's and Cushing's. We're also going to talk about hypoglycemia as well as everybody's favorite diabetes. From there, we're going to move on to talk about the differences between DKA and HHS, as well as talking about the differences between DI and SIADH. And then finally, we'll wrap things up with talking about the difference between thyroid storm and myxema coma. So stick with us through the series. We've got a lot of great lessons coming up for you guys. And so with that said, if this is your first time to our channel and watching our videos, I do want to invite you guys to subscribe to our channel below. We consistently put out great critical care educational content such as this video here. And if you'd be interested in continuing to receive this education, then hit the subscribe button down below, but also make sure you hit that bell icon, that way you'll get notified anytime our new lessons become available. And as always, I truly value the subscriptions that you guys give us, the likes, as well as the comments that you leave for us. It really goes a long way to support videos like this as well as our channel, and for that I do want to thank you guys. Alright, and so with that said, let's go ahead and start into our first lesson here doing our overview of the endocrine system. My name is Eddie Watson, and this is ICU Advantage. So to really start things off, I really want to begin and kind of talk about what exactly the endocrine system is. And to really sum it up simply, what it does is it regulates the body's internal environment. And so our body does this through the use of these glands, which we call endocrine glands. But it's important to differentiate between the endocrine glands and these other glands that we call the exocrine glands. Now, each of these glands are glands because they produce hormones, which we'll talk about in just a minute here, but our endocrine glands will secrete these hormones into the bloodstream, while the exocrine glands are going to secrete these hormones into ducts. And those ducts are going to carry those hormones to some external place. And so with the endocrine system, it's actually going to be working very closely with our nervous system. And together, these two systems are going to be regulating things like growth, reproduction, sex differentiation, metabolism, fluid and electrolyte balance, and that internal homeostasis. But it's important to know that the nervous system and the endocrine system are not duplicating each other. They're actually working in complement with one another. And so to review for the nervous system, basically this is where it's releasing neurotransmitters at synapses at specific target cells, and this is causing some sort of effect. This is a local and specific effect that's going to be being caused here. And the nervous system reacts very quickly to stimuli, in fact a matter of milliseconds, and then when it stops, it also stops very quickly. Whereas when we look at the endocrine system, it's releasing hormones into the blood that are going to impact target cells and cause an effect themselves. So this has a very widespread effect throughout the body. And because these hormones are having to go into the blood, this system is going to react slowly. So here we're talking seconds to sometimes even days. And then once that stimuli is stopped, you may continue to have a response after that stimulation is over. And so here we can see that really the big differentiation between the endocrine and the nervous system is the use of these hormones. But it helps if we have a little bit more understanding of what these are in order to have a good foundation for understanding the endocrine system. So essentially, hormones are chemical messengers that they have an effect on target cells that are distant from the cells that secreted them. And there's really three subcategories of hormones that we can talk about. We have the endocrine, the paracrine, and the autocrine. Now what we're going to be talking about mostly is what we refer to as the endocrine hormones, and these are the ones that are in the bloodstream, released into the bloodstream. But we also have these paracrine hormones, which are going to be released and act on neighboring cells. And then finally, we have the autocrine hormones, which are going to be released and act on the self, or the cell that has secreted them. And so when we talk about hormones, we can talk about these different chemical messages. And these hormones are going to act on specific receptor sites on target cells. So let's imagine that we have a target cell that's over here. It's going to have specific receptor sites that will only match up with specific hormones. So in this example here, this hormone would fit, but if this other hormone came along, it would not bind with that receptor site and would not cause any effect within that cell. And so really you can think of this almost like a lock and key. So it's going to take a specific key for a specific lock in order to activate that response. And then some cells can have multiple receptor sites for different hormones, and some cells will have just specific ones for a specific hormone. But in order to initiate that effect, you're going to have the right hormone to bind with that receptor site. There's two different ways in which these hormones can bind with receptor sites on the cell. The first is like the example that I drew here, where these receptor sites are on the surface of the cell, and this causes some secondary messenger to take place inside the cell, ultimately leading to whatever the effect is supposed to be. Others are going to be located within the cell. And so here the hormone must actually enter into the cell in order to bind with that receptor. And this is usually going to directly influence the synthesis of some sort of protein that's going to give us the effect that we're looking for. And really our differentiation for where these hormones are going to interact with their receptor is based on whether they're going to be water soluble or lipid soluble. And we'll talk about that in just a minute here. And so let's look at and talk about the different categories. And there's really three categories of hormones that we're going to be looking at. The first of these is what we call the peptides. And essentially these are our protein hormones. And our peptide hormones are going to be our water-soluble ones. So this means that they're going to interact with those receptor sites on the cell's surface, because they're not going to be able to penetrate the lipid bilayer of the cell surface. And examples of these are like vasopressin, or the antidiuretic hormone, insulin, growth hormone, etc. The next category of hormones is what we call our steroids. And we can think of the steroids as our lipid-soluble hormones. So again, these are the hormones that are going to go inside the cell and interact with those receptor sites inside of the cell. Example of the steroids are things like aldosterone, cortisol, progesterone, and testosterone. And finally, the last category is something that we call the amines. And these are kind of like peptide hormones because they're actually amino acid derivatives. And so these are very interesting because depending on their configuration, they actually can act different ways. So examples like epinephrine and norepinephrine are actually going to act on the membrane of the cell, whereas T3 and T4 are going to behave like the steroids and act inside the cell, even though both of them are made up of these amino acid derivatives when it comes to the type of hormone that they are. All right, and so the next thing that we're going to talk about now is the feedback mechanisms that we deal with when we're working with hormones. So some of these hormones are going to act for a short period of time and with a small amount of the hormone, while others are going to have a long period of action. And this can really be a very complex and intricate set of controls that are going on within this endocrine system. And the release of these hormones is really going to be regulated by either some sort of positive feedback mechanism or some sort of negative feedback mechanism. Although the vast majority of them are going to be working off this negative feedback. And so in order to really help give you an understanding of this, you have to think about if we have some sort of stimuli, and that's going to trigger the secretion of hormones, which, as we know, are going to cause an effect on some target cell. Now, this effect that they have on the target cell is actually going to go back and cause a decrease in the stimulation for the production of the hormone. And so this is that negative feedback loop. And so we're going to talk about some of these glands here in a minute, but a really good example of this is the pituitary gland releasing thyroid stimulating hormone. This goes to the thyroid, which causes it to release T3 and T4, and the T3 and T4 is going to go out into the body and have its effects on target cells. But in addition to that, T3, T4 also inhibits the pituitary in releasing the thyroid stimulating hormone. So now because we have enough of this T3, T4 floating around, the pituitary is going to have less of an inclination to ask the thyroid to release more T3 and T4. Alright, so that was a pretty good overview now of the endocrine system and some of the differences that we see within that system. And so the next thing that I want to move on and talk about is some of the anatomy and physiology related to the endocrine system and what these different glands are and what they're for. And so as you can see here, we have a pretty complicated set of several different glands that oftentimes are going to be working together to achieve the various effects that we're looking to see. And so what we're going to do is we're going to go through and talk about each of the different glands within this endocrine system, as well as talk a little bit about what those glands are for. And so to start off, we're actually going to take a look at our brain. And within our brain, there's actually 3 different areas that we are going to talk about. All right, and the first of these is actually located right about here. And this is something that we call the hypothalamus. And you can really think of the hypothalamus as our control center. And the reason for this is the hypothalamus is our link between the central nervous system and the endocrine system. So it's going to take stimuli that are coming in the form of impulses from within the brain, and it's going to pass those signals along to the pituitary gland, which is the next gland that we're going to talk about, and you can find that right about here. And the pituitary is a little pea-sized gland that's just hanging there. And we can really think about this as our master gland. Because as we just talked about, it's going to take signals from the hypothalamus and it's going to send out those signals to almost all the other endocrine glands, essentially controlling them and telling them to release their hormones. And there's 2 parts to the pituitary. We have both the anterior as well as the posterior. And the different parts of the pituitary gland are going to release different hormones. The posterior is primarily responsible for our antidiuretic hormone, or vasopressin, as well as oxytocin, while the anterior is going to be responsible for releasing TSH, luteinizing hormone and follicle stimulating hormone, prolactin, growth hormone, and ACTH. And so, like I said, these hormones are going to go out to many of the other organs in the body and stimulate them to do certain things. Like, for example, TSH, the thyroid stimulating hormone, is going to go down and have an effect on the thyroid. Luteinizing hormone and follicle stimulating hormone, those are going to go out to the gonads and have their effects there. But we do also have things like growth hormone, which is going to go out and it's going to have an impact on our muscles, our skin, our bones, things like that. And so finally, the last gland that I want to talk about within the brain is located right in here. And this is what we call the pineal gland. And you can really think of this one as our sleep gland. And the reason for that is it's going to be producing melatonin to help us sleep. All right, so that covers the 3 glands that we're going to talk about within the brain. And so next we're going to move on and talk about the thyroid. Now we can't talk about the thyroid though without actually talking about the parathyroid glands. And these are typically found in 4 different locations on the thyroid. But these glands have very different functions. So first, let's go ahead and talk about the thyroid. And so you can see the thyroid and the parathyroid over here, and it actually wraps around the trachea. And the thyroid itself is responsible for releasing T3 and T4. And T3 and T4 play a lot of different roles, but really you can think of this as our metabolism regulation, our tissue growth, and it also helps to regulate our blood pressure. Now next we'll talk about the parathyroid glands. And like I said, you'll find those actually located right here, the green dots that you see on the thyroid itself. And the parathyroid, it actually releases the parathyroid hormone. And the main goal of the parathyroid is to regulate our calcium levels. And we know that calcium is important in our body because it plays a role both in muscle contraction and bone growth. Now, moving on down in the body, the next gland that I'm going to talk about is this gland right here, and this is what we call the thymus. Now, I'm not going to cover much on this because it really doesn't play into the endocrine system as we really think about it as a whole system, but the thymus plays a very important role in the development and maturation of our T cells. So, immature T cells will actually go to the thymus, in which it will excrete its hormones to help to develop those T cells into mature T cells to be able to go out into the body and to fight off disease. So definitely has an important role in our body, but when we're talking about this endocrine system that we have here that's really kind of working together, this one really kind of falls out of the line of that. Now the next organ that we're going to talk about is this one right here, and this is what we call the pancreas. Now, the pancreas is kind of similar to the thymus in the fact that it doesn't actually take signals from the pituitary gland in order to function and do its job. And that's because the pancreas is responsible for the secretion of insulin and glucagon. And insulin and glucagon play a very important role in our blood sugar regulation. And so our insulin will actually be secreted as a result of eating, while glucagon is going to be secreted as a result of fasting. And so insulin, after we eat, is going to cause that blood sugar to come down, whereas glucagon, if we haven't eaten in a while, is going to stimulate the liver to provide the body with the energy that we need. All right, so continuing our journey down, we're next going to talk about two glands that function together, and they both are located right here on top of the kidneys. And these are what we call the adrenal glands. And the adrenal gland is broken up into two parts. The first is what we call the cortex, which is the outer part. And the other is the medulla, which is going to be the inner part. And so the cortex is going to be responsible for our steroid production. And so this is going to be our cortisol and our aldosterone. The cortisol plays an important role in our stress response, while the aldosterone plays an important role in our fluid regulation. Now, when we take a look at the medulla, this is going to be responsible for our catecholamine production. So here, think of our adrenaline or epinephrine and our norepinephrine. And these two play a very important role in our sympathetic response, and this is where you can think about that fight or flight. All right, and so finally moving down to the last two organs that we have on our example here, which depending on if you are male or female, will determine which one of these you have, and these are going to be our gonads. And so these obviously are going to be either our ovaries if you're a female or testes if you're a male. Now the gonads are going to be responsible for releasing our sex hormones. And these sex hormones are going to be responsible for many different things, including our secondary sex hormone response, as well as puberty, menopause, things like that. And this is where you're going to be looking at, if you're a female with the ovaries, you're going to have estrogen and progesterone. Whereas for the males with the testes, that those are going to produce testosterone. All right, so this pretty much covers the overview of these glands within our endocrine system. Although it is important to know that there are other organs within our body that do have clusters of endocrine cells that are releasing hormones, but it's not their primary purpose. So some examples of this are the heart, which can release both ANP and BNP, which ANP regulates our blood pressure and our blood volume, whereas BNP is released in response to stretching within that heart, as well as the kidney itself is able to produce erythropoietin, which promotes the production of red blood cells, as well as it also produces renin, which is going to be associated with that release of aldosterone. The stomach and the intestines, they also release hormones that control our digestion. And then even our bones, skin, and our adipose tissue, which releases leptin to tell our body how much fat is in there, all of those also produce hormones as well. But the important thing is with these organs, while they do have those endocrine cells that produce those hormones, that's not their primary function. They just happen to do that as a byproduct of something else that they need. All right, so that was a pretty in-depth review, both of the anatomy and physiology, as well as the basic foundation of what the endocrine system is. Hopefully you now have a better understanding, like I said, a better foundation to stand on with understanding what actually the endocrine system is, because as we move forward with the remaining lessons, we're going to talk about some of the disorders that result from the lack of production or overproduction of some of these hormones within these glands. So it helps to have a good understanding of what these glands are, where they are, what they're doing, and what sort of hormones that they're responsible for, because when we start to talk about these disorders, it will make a little bit more sense for you guys. All right, so with that said, I do want to thank you guys for watching. I really hope that you guys found this lesson to be useful and enjoyable. If you did, please hit the like button down below, as it really goes a long way to help support our channel. As well as, if you haven't already, make sure and subscribe to our channel. In the next lesson, we're going to start our dive into some of these disorders that you're going to come across within the ICU related to our endocrine system. And for these, we're going to be talking about our Addison's versus Cushing's. In the meantime, feel free to check out the last series of lessons we did, in which we did an in-depth coverage of heart failure. As always, I want to thank you guys so much for watching, and you have a wonderful day.